Hello, world. Good morning, good afternoon, and good evening. It's great to have everyone from Jamaica to Jersey, Armenia to Colombia on board for Hello, World, a practical introduction to data science and programming for policymakers. If you're new to us, welcome. I'm Sean Long, Community Manager here at Apolitical, the global peer-to-peer platform for government. And here with me are a few members of Apolitical's engineering and data science team, Dr. James Smith and Dr. Patty Alton. Our purpose today is to help you harness the power of programming and data science to maximize your impact. This is an introduction for people from all backgrounds, that you come to us with different stories. I'll hand it over to James and Patty now, who will give a big picture overview, then help you write your first lines of code and understand what it means. And with that, I'll hand it over to you.
Great. Thank you very much. Hello, everyone. It's great to be doing this. Thank you all for joining us. As Sean says, we're going to take you through some basics of data science programming for policymakers and why it's helpful to understand this stuff a little bit and how it can help you day to day. Quick introductions. First of all, I'm James Smith. I am the head of engineering at Apolitical. Previously, I was the head of the labs program at the Open Data Institute, and I've been a software engineer and technologist for 20 years. I'm passionate particularly about open source, open collaboration, and the power of the web to connect us all.
I'm Paddy. I'm a data scientist and engineer at Apolitical. Before I joined Apolitical, I was working on my doctorate in astrophysics, and I'm now applying the skills that I learned there to help power up public servants. So James is going to open the first half of the talk on programming skills, and I'm going to do the second half on data skills.
So, just to give you an idea of what we're going to go through, at the end of this session, we really want you to be able to explain why data and programming are useful in a public service context. You will be able to read some simple Python code and understand what it's doing. And you'll be able to use that code to obtain data from the internet, perform some basic cleaning and analysis of that data, and then we'll give you some pointers on how to explore further learning materials with confidence. So this is an interactive presentation. So we'll be showing you some code, but you can follow this along as well. If you have a modern web browser, Chrome and Firefox work best, and a Google account, you can take your own copy of our interactive workbook, which you can see linked on the screen there and is also in the email that you will have been sent about this. And you can follow along, and you can do that during the talk, or you can do that afterwards in your own time as well. You can use it to explore programming, which is really the best way to learn it, is to have a go. So let's start with the basics, really. What is programming? And programming, or coding, you may have heard it called that, it's really the method that we use to tell computers what to do. And computers are deceptively simple, really, or deceptively complex. But they take inputs, they produce outputs, and something in the middle decides how to turn one of those into another. And that something in the middle is what we create when we're programming. Within computers, they talk a totally alien language, which we call machine code, and this is the ones and zeros that you'll have heard of that actually tell the machine what to do. And when this industry started out, we started out having to program that directly, to write these things manually in something a very long way away from human language. However, as time goes on, we've produced languages that are more and more like natural human languages. Usually English. There are some in other languages as well. But we can get the computer to convert those into machine code. So we can tell the machines what to do in something much more natural for us, that's much easier to think about. And there are lots and lots and lots of these languages. Today we're going to show you Python, which is a very popular language for learning, for data processing, and many other tasks. But there are many more that you'll have heard of: JavaScript, C, Java, HTML, R. So many, it's ridiculous, and it's very hard to keep up with. Even for professional engineers, it's always it's a continuous learning experience. But also there are other ways, other paradigms of programming, and even something like spreadsheets can be thought of as programming, because you are putting in some data, you're transforming it, especially using formulae and things like that, to produce outputs. So a lot of the similar ways of thinking apply to those levels as well. So many of you may be doing some programming without even realizing it. So why do we do this, and how is it useful sort of day to day? Why do we write this code? The big one is repeatability, really. If you give the machine the same inputs, it will produce the same outputs. The computers will only do what it's told to do. They can seem chaotic and unpredictable at times. We've all felt that, but that's an artifact of the complexity of the entire system at the level of individual pieces of code. This repeatability is an essential part of it. And because it's repeatable and predictable, we can use it for automating common tasks and doing them very, very quickly. So, we don't have to work out these same things time and again using laborious methods. We can write the code once and then just run it across a whole load of different information, and it'll work the same way each time. So I mentioned spreadsheets, and this repeatability and automation is something that people do a lot with those. And you can do a lot of what we will show you today in a spreadsheet environment. But by learning a bit of code, you can go a lot further. So this is really a sort of an on-ramp that hopefully you can map across to stuff that you might know from a spreadsheet type environment, but it's also an entry into a much larger world. So a big question that we get is as a policymaker or as a civil servant more generally, why do I need to know this stuff? I don't, I'm not building, I'm not programming day to day. Why do I need to know this? And how can we convince other people that it's important as well? And I think it comes down to a question of sort of literacy around the modern world. Now, these days, computers are everywhere. We don't have cars, we have computers that can drive. We don't have airplanes, but computers that can fly. There are computers in your house, in your pocket, multiple computers in your car. They're everywhere. And the internet and the web have fundamentally changed the way we communicate. And understanding a bit of programming, a bit of what's going on inside the black box will help you to develop intuition about what the machines are doing, what they're capable of, and what their limits are, all of which is relevant if you're trying to apply policy ideas in the modern world, because this stuff is fundamentally part of where we are now. So we're going to start the interactive section of the talk. I'm going to take you through some basic programming concepts, and then I'll hand over to Paddy to take you through some stuff about data. So here again on the slide here is a link to our interactive notebook. You can open that up. You can follow along, and the notebook is another evolution of that step towards natural language, in that it's now it's like a document in a way. It combines a description of what's going on with the code as well. So you can actually use these to do your calculation and write your code, but also to explain what's going on, which in any context really is very important. It's a very new tool. We wouldn't have been able to do this really only a couple of months ago. So it's a great thing that we're going to show you. So we're going to run through some example code, like I say. Throughout all of this, we're building up towards that end goal that I talked about earlier of being able to grab some data off the internet and do some analysis of it. But we'll start small and go a step at a time. So I'm going to switch over to our interactive workbook. And you can see here it looks very much like a Google document. A document with description, titles, all that sort of stuff. The first thing you're going to have to do to follow this along is take a copy of it with this copy to drive button here at the top. That's going to take a copy of that notebook into your own Google Drive, where you can edit it, change it, and run it yourself. And just before we start, the next thing to do once it's taken that copy is to select Run All from the Runtime menu, which is going to fire up something in the background that's going to run all this code and produce those results. So now we've done that, we can get started. So in this document, each of the, you have these text sections, but then you have the shaded sections that you can see, and those are the actual code that we're going to be working with. And you can see it's written in lines, much like any other document. The computer reads those lines one after another when you run your program, and each one is an instruction. So this first section here, this you can see has the section 2 label here, is a simple line of code that makes what we call a variable, which you can think of as like a box to store information in, and it puts the number 185 in that box. So the variable is called my height, and I've stored 185 in it because that's how tall I am. If I wasn't, I can change that, and you can go in and enter in your own height into here, and then rerun the cell by clicking the play button at the side. And you can see what's happening here is we have put that value, that number, into the box, and then we're using this print call here, which we'll explain a little bit more about later on, to print out the value that's in that box, to look into it. So we can see here that's changed to 175. So we can use the box instead of the number. We use the variable instead of the number, like algebra in maths, very similar. And we can do calculations with it. So let's say we want to work out how high doors need to be so that we don't bounce off them. We can use my height and then add on another 30 centimeters, for instance. And if I run this with the updated height, we can see that my doors need to be at least 205 centimeters high. And that's so that's showing you can use these variables to do those calculations and create new variables as well. So that box has just got one thing in it, the number 185, but you can put lots of different things into those boxes, into those variables. The next block number 4, is instead of a number, it's storing a piece of text, which we call a string. So to say my name is a policymaker, which you can change to yours. I will change to mine. And then the line below that is combining that name with the height that we had earlier to print out a combination of those bits of data. So you can store lots of different types of information in variables, numbers of different forms, whether they're integers, whether they're decimals, strings, and lots of other things. The next type of information we're going to look at is what we call a list. So in section number 5, we're creating a variable again called cat names. And instead of just storing one thing in it, we're storing 3 strings in a list, these square brackets with these 3 strings in it for the names of some cats. So I'm going to, and you can do the same if you have a cat, or invent your own cat name. You can. I'm going to add the name of my cat, and you can work with those lists. Now, when you want to look at the list, before we were just looking at the variable and printing that out. When we're looking at a list, we need to look at what is in each position. So in section 6, you can see if we print out cat names number 2, we get the name Derek. Rather than that whole list, we just get one element of it. Now, the observant amongst you will have noticed that we asked for number 2, but it gave us the 3rd element in the list. This is because computers count from 0. So you have to get used to thinking of the 0th item in the list. So if we ask for cat names 0, we get tiger, which is the first one. So our list is indexed from 0. Each item has the index 0, 1, 2, 3, which takes a little bit of getting used to, but becomes second nature fairly quickly. So a list is a type of collection. It's an ordered collection used to store a sequence of information. This isn't the only way to organize that. The other type we're going to use later on is called a dictionary. And if you look at section 8, you can see we have a dictionary. And a dictionary combines, rather than having just a sequence, you have a number of keys and a number of values. And the keys in this case are country names, and the values are the populations of those countries. So we can once again add a new key. Let's add the UK, and I realised that I can't remember how many people there are in the UK, but it's something around
67 million.
67 million, thank you. Obviously, I don't know exactly. And you can add any number of items to those dictionaries. So we're going to be using that later on. We'll come back to that. But to access, rather than using the index like we did with the list, to access the information in that dictionary, we can use the key. So we can look up the population for Indonesia there, or by changing the key, we can look up the population that I just added for the UK. Or you can't. See, I have forgotten to rerun the cell. You have to rerun the cells in the right order in order to do that. So that was an intentional mistake to show you that everything happens in order. So I've gone through basic concepts of variables, numbers, strings, lists, and dictionaries, and that's enough really for you to start to explore data. So with that, I'm going to hand over to my cohort, Dr. Alton here, for an introduction to data.
Thank you very much, James.
So on the slides there.
That's right. We'll go back to the slides and then we'll pick up the interactive exercise in a little while. Okay, so data. What is data? Well, one way to go forward would just be the simple definition. Data are facts and statistics collected together for reference and/or analysis. That's a very broad brush definition and quite abstruse. Data could be a list of cat names or population statistics for different countries. It could be in the form of numbers, text, images, all sorts. Indeed, one of the most important trends in our society right now is the rise of datafication. That's a phrase coined in 2013 to describe the collection and storage of data from an ever wider variety of aspects of daily life. And this data doesn't simply appear, it's created. It's important to understand how it was created, when, and by whom. Buildings have sensors strewn throughout them now, as do cars, creating data on infrastructure use, which is used to detect failures or to predict them in advance. Supermarket loyalty schemes have turned our purchasing habits into data. Twitter has even turned our idle thoughts into data. So there's data on everything, increasingly all stored electronically and ever more widely accessible. But what's all this got to do with public service? Why do you need to know it? Or perhaps more relevantly, how can you persuade other people of its importance, since you're already here? The answer, of course, is first and foremost that policy works best when it's based on evidence. That is, when you have a good level of certainty that a particular policy that you are implementing will contribute towards achieving your policy aims. That isn't a new idea. To illustrate that, let's go all the way back to a key moment in evidence-based policymaking, way back in 1854. So this is an example of data-driven policy from the public health sphere in the Victorian era. In 1854, there was an outbreak of cholera in London, just down the road from our office, in fact. People were terrified of cholera. It had first arrived in 1831 during a global pandemic and had killed thousands of people. In this case, an acute outbreak killed hundreds of people in a matter of days. And no one really understood how disease spread at the time, and the prevailing theory was that it had something to do with bad vapours, or miasma. However, Dr. John Snow had a different theory, and he set out to investigate. And what we have here is a segment of the original map that he created, which is really an infographic, not a map at all. The black bars show the number of cholera cases at different properties in the area of this outbreak, and the segment shows the epicenter of the outbreak. You can also see marked on this map the Broad Street pump, and that's relevant because Snow's theory was that cholera was waterborne, and the evidence which pointed to the pump seemed to confirm this. So what did he do? He urgently contacted the local government and convinced them of his findings. He was said not to be a charismatic speaker, but a good data visualization can be very persuasive. So they removed the pump handle, and the outbreak subsided. Now, it would be a simplification to claim that his theories were widely accepted overnight or that policy dramatically pivoted. But what we do know is that a year later, legislation was passed that paved the way for the construction of London's Victorian-era sewers. Although, to tell you the truth, this may have had as much to do with the terrible smell outside Parliament as public health per se. So what's changed since 1854? First, the democratization of programming and the spread of open data mean that these days it isn't only experts who can gain the insights hidden away. That's something that we're going to show you today as we explore our own data sets. But another major change is the rise of big data. At one level, big data just means we're collecting an awful lot more of it than ever before. But the phrase also hints at the incredible insights that you can derive from data if only you have enough of it. Data at scale is driving many of the key technological changes in our societies: the automation of decision-making, the rise of smart cities, the development of driverless cars. And how is it doing that? Well, it's not just about how much data you have, but also how you analyze it. A human analysis of a small, relevant data set can still yield valuable, life-saving insights, and that will remain the case for the foreseeable future. But at the intersection of programming and data analysis lie machine learning and artificial intelligence. The automatic production and refinement of data analyses allow for faster, smarter decision-making and better predictions of and responsiveness to events. This is revolutionary, and at Apolitical we regularly publish stories on our website regarding cutting-edge policy applications of machine learning and AI. The immense and growing capabilities of AI may seem mysterious, but if you understand how to do simple data analysis using a programming language, you're more than halfway to demystifying how AI works. And as a corollary, understanding what its potential and its limitations are. So we're now going to continue our tutorial by diving into dealing with data in the Python programming language. And it's true, we can't teach you everything in an hour, but I want to show you that you're not so far as you might think from being able to do many useful tasks of the kind that regularly come up at work. Perhaps the sort of tasks that might usually have you reaching for the spreadsheet software. I hope this will encourage you when you follow up this session by learning some programming basics, since it can be hard to see where you're going at first. You need to have certainty that there will be a quick payoff for your time. But more to the point, Python has become the industry standard programming language for artificial intelligence and machine learning. If you become proficient in Python, you have the foundation required to understand these, their potential, their limitations. So the sky really is the limit. Now, before we jump back into the interactive exercise, I should remind you that data comes in many different formats. Today, we're going to focus on working with data organized in tables, as that's a format I think you'll all be familiar with, and with which we can quickly get started. Of course, data can also come in less structured forms, and Python also has ways of dealing with analysis of those different forms. Lovely. Okay, so here we are. This is our interactive exercise, and we're going to pick it up again at this section, what is data? So as I've just explained, data can take many different forms, and we're going to be looking at data which is organized in the form of tables. And that's something which is easy to get started with in Python. So the next line of code that we're going to look at gets hold of a code library called pandas. That's a Python data analysis library. You can probably hear an acronym in there somewhere, or maybe not. Python libraries contain code suited to performing particular tasks. Just like you might open up a spreadsheet program on your computer to deal with tables, so we import the tools that we need into this notebook. So we have this line, import pandas. That's all we need to do. Just run that line, and now we have access to that set of tools. Data in tables, of course, consists of columns and rows. So we've created a fictitious example here to illustrate this. Each row in this table corresponds to a person, while each column is a particular measurement or observation that we've made about that person. This is a best practice for tabular data. So each row is an observation, and each column is some aspect or characteristic of that observation. Now, the pandas library, which we've just imported, gives us access to a special collection, like the lists and dictionaries that we looked at previously, except for tables. And that collection is called a data frame. You can make one of those as follows. Let's review what we did. So first, we created a dictionary called raw data. And in the case of this dictionary, you'll notice the keys are the column names, and each corresponding value is actually a Python list containing the data in that column. Next, we used a special command, pandas.dataframe, which we use to act on the raw data, and that just tells the computer to turn the raw data that we've just defined, that dictionary, into a pandas data frame. So let's see that data frame on the next line. We'll print it out, and you can see this is very clearly a table. Things to notice about this. The column names are at the top, and you'll notice that they've been alphabetized. Each row has a number down the left-hand side, starting from 0, just like the way that the list was indexed. This is called the rows index. You can select a particular column in this way. So the next cell, you can see that we've, just like how we got data out of dictionaries using its key, so we're able to get a column out of a data frame using the column name. We could change the name of the column that we're looking at. You can see that we get that data out instead. You'll notice that the column has retained its index, but is no longer a fully fledged data frame, although in many respects it can be used in the same way. Pandas calls this a series. If you've ever used a spreadsheet, you'll see that the column names in the index are analogous to the column letters and row numbers that you find in a spreadsheet. And just as you can click on cell B2 to get its value, so in the data frame, you can get the value of a particular cell. Here's how you do that. .lock is a data frame's locator. Here we have selected the row 2 and the column country. Referring back to the table, you could try changing the row and the column in the block above and rerunning it. You need to make sure that the value that appears under the block is what you expect. So to give an example, we could change country to name. Pull out row 3, which you'll recall is actually the 4th row. You can see that we've got out the item that we expect. Okay. So that's how you get some data into Python. But that's only the first step. With new data, we typically want to undertake an exploratory data analysis, or EDA for short. An EDA can take many forms, but all approaches have the same goal: to uncover patterns or features that exist within the dataset. Our example data is very simple. With only 3 rows and 4 columns, you might not think there's much to explore. Yet even a simple small dataset can yield insights. And so how do we do that? Well, Pandas has a variety of ways of calculating summary statistics for one. Most straightforwardly, if we run this line, then we can see that we have generated a variety of common summary statistics on all the data frame columns that contained numerical data. So that's just the age and height columns in this case. This is called the describe method. Method is simply the proper term for code written in this manner. So data frame dot method is used to do processing on the data held in a data frame. And you may recognize what some or all of these summary statistics mean. So, for example, as the count, that's just the number of items in each column. You also have the mean, so the average value of the items in the column. And there are some more complex statistics here, such as the standard deviation and various quartiles. Okay. But what about non-numerical data? A good approach with that kind of data can be to count the number of occurrences of each value in a particular column. So, for example, what we're doing here is we're using a method called value counts. And this series that it's generated doesn't tell you anything you didn't already know, because you looked at the table before, but it's a method which will come in handy when we deal with larger data sets. It's just telling us that there are 2 entries for Italy, 1 for Ethiopia and 1 for Indonesia back in the original table. That's in the country column. Note that the value count series is indexed by the countries. The index of a data frame or a series doesn't have to be the row numbers, that's just the default. Now, often we are not interested in the entire data set and would like to explore only a subset. Pandas makes this easy. Previously, we used the data frames locator to get the value in a specific cell, but we can also use it to get specific columns of data. The next line of code does just that. You should think carefully about what we did here. Rather than put a particular value of index and column into the locator, we gave it a list of index values and a list of column values, and this gave us a new data frame with all the selected rows and columns. We could try rerunning this data frame, this line with different choices. So we can use a different column and we can add another row. You can see how that's changed the output. Visualization tools play a very important role in exploratory data analysis, and so Pandas provides a whole suite of them. Here's one example. This is creating a scatter plot. So what we're doing here is we're plotting on the X horizontal axis height, the values of the height column, and on the Y-axis, the vertical axis age, so the values of the age column. And this is just a scatter plot, and we've made it a fetching shade of blue. So you can see there's a lot of options for customizing these data visualizations, since it's so important to get them right. And this line of code has created a scatter plot. These plot methods are designed to be intuitive, and a variety of different types of chart are available. So here's another kind just to demonstrate that. Once again, we're going to use the value counts method, and we're going to apply that to the country column. Only this time we're going to immediately use the .plots.pie method, which of course makes a pie chart, as you can see here. And this counts, as you remember, the value counts method counts the number of occurrences of each unique country in each value in the country column. We then immediately use the .plot.pie method by chaining the methods together, and it's the ability to chain methods together like that that makes Pandas extremely concise. And that allows you to focus on results rather than the details of the code. Okay. So I think we're going to move on to our next section now. Where does data come from? James, I think you're going to pick that one up.
Yeah, absolutely. Thanks very much, Paddy, for taking us through data and how to work and analyze it. And I'm just going to finish off this the interactive part of this by talking a little bit about getting hold of data and then working with some real data. So as we mentioned earlier, data's becoming more and more open. There are lots of open data sets out there, and of course, organizations have lots of data that is collected, particularly governments and things like that. So how would we work with something like that? So let's have a look at, we're going to look at a freely available data set from data.gov.uk. It's stored in CSV, very common type of data which you could open in a spreadsheet program. And Pandas makes reading that off the internet really, really easy. We have the the URL, the location of that file. As you can see here, we can just say pandas.readcsv with that URL, and there we go. We are doing a couple of things here. We're skipping the first 4 rows because actually in this CSV file there are 4 empty rows at the beginning that don't have real data in them. They have a title. So sometimes you have to do a little bit of cleaning of the data just to be able to load it, because a lot of data is not yet published in the best possible way for machines to look at and understand. And then what we're doing is we're using this .head method just to print out the first 3 rows of this data set. There's lots and lots of rows. And you can see we've got this real data, which is, this is a data set from the Ministry of Defence in the UK about pieces of land that they are selling off, where they are and when. So you can see we have lots of information there. And this might be relevant to a number of different people within civil service, within government. You might be working for the Ministry of Defence. You might be working for an MP who wants to know how much land is being sold off in their constituency. You might be working for a local council. You might be working in housing, looking for what could be built where. So there's many different uses for this data, and the nice thing about publishing data openly is, of course, that people can find their own uses for it. So we've loaded in that data set. It's all there. We're only showing the first 3 rows here, but it's all there, and we can use some of the techniques that Paddy has shown us to do a bit of analysis of that data. So here we're using the value counts method to count up the number of rows with each different value in the status column. And we might do the same with the county, for instance. So we can look at the what's available in which, what's being sold off in which county. And we might, once we've got that, we can then use the same tools again to plot that on a graph. So we've done the same value counts for the counties. We're looking at just the top 10 here using the same head method that we did earlier, and then plotting it as a bar chart. And we can see that it gives a very clear view of what that data looks like. So yeah, if you're in Hampshire, Cambridgeshire, and Essex, you'll probably have some interest in that data if you're those councils. So we can also look at other aspects of the data. So let's have a look at what's going to be sold off when. How quickly is this stuff being sold? If we do value counts for the forecast FY, which is the year that it's going to be sold, we can count up the number for each year. Those won't be automatically sorted into order for the year, so we use this sort index method to give us a list of disposals per year, which we can then do exactly the same thing with and plot on a bar chart. So again, you might this might be a useful way to present that data. So there's a number of things here where we've just combined each of those little techniques that we saw earlier and combined those into a simple analysis of a real world data set. Now, as we say, you could do a lot of this by loading that data into a spreadsheet program, but this is the first stuff you can do here. You can go a lot further. You can do a lot more detailed analysis, and of course, it's going to be much more repeatable. So I'm just going to pop back to our slides. Do we have we had any questions from the audience we want to address? Okay, we will be sending around some links, but what we've got here are some follow-on links for how you can continue to learn and what the next steps are on your journey. We would particularly recommend, Paddy recommends this, there's a tool called Anaconda, which you can find a link to here, or just Google Anaconda for Python on the web. And that is it's an out-of-the-box Python programming and data environment. Paddy, that's one that you particularly recommend. Yeah?
Yes, that's right. It's the original framework in which these notebooks that we've just been using in our browser were provided. And it's got a whole load of useful tutorials as well, so you can really get started quite quickly. It works on various different operating systems, so you don't need to worry particularly about what kind of computer you have. You just get started, and it's particularly well optimized for data science. It has a lot of tools to deal with data analysis. So it's a great place to start, in my opinion.
Yeah, it's a good one. If you are working particularly with data and do a lot of cleaning and analyzing, there's a tool that I'd recommend you look at called OpenRefine, which is like a spreadsheet program that you're familiar with, but comes with a lot of extra tools for working with data, for linking it together, for looking up different data sets and so on. That's well worth a look if you're in that kind of spreadsheet environment. And I'd also recommend this if you have there's loads and loads of programming resources out there. There's lots of great stuff. One that I've been using recently, actually, with my daughter is called Swift Playgrounds, which is an app on the iPad where you can learn some programming and learn to code in a language called Swift by walking a little monster around the screen, which is, a great way to engage children, but actually I found it really good fun as well. So I'd highly recommend that. And there's some more links and resources as well. Paddy actually has some follow-on notebooks that go into more detail on Python that we will share as well.
That's right. Today we've driven from A to B in a straight line as fast as possible. So we've got some follow-on materials which help you really lay the foundations and get started with these other tools that we're going to provide to you or signpost you to.
So hopefully today that's been useful to you. Hopefully you can now go out and explain a little bit about why you need to, why it's helpful to dig into this stuff a little bit more, to learn why data and programming are useful beyond just a pure programming context. Hopefully you've been able to follow along, read that simple Python code and understand what it's doing and why. And we've gone through that process of obtaining data from the internet, cleaning it, and doing something useful with it. So hopefully you can continue your journeys from here. And good luck. I guess it's a very rewarding thing to learn, I find. So it's great fun. It's very satisfying when something works. So enjoy.